Here we are once again doing another test with the robotic blacksmithing system. So let's go ahead and home the system and get started. Now that we're in the home position, we can send the robot to the scanner mount where we can load in our workpiece. So here we have the new and improved gripping mechanism. So this mechanism can be locked in the open position. We can insert our stock. We can close the gripper. It automatically pulls back, and this ring tightens the 4 jaws against the stock. It also self-centers the stock, just like a 3-jaw chuck in a lathe. This mechanism can also be opened, and the stock can be removed. And we can put it back in as many times as we like. Above the workpiece, we have mounted a Scan Control 2900-100BL 2D profile scanner. It projects a blue laser line down onto our stock. The stock can be rotated under this line, allowing our 2D profile scanner to collect a profile at every angle around the workpiece. And from those 2D profiles, we can construct a 3D model of the workpiece. This workpiece today will be subjected to multiple forming operations, and after each forming operation it will be 3D scanned, and in the computer we will be able to see multiple 3D models showing the progression of the forming operations, culminating with our final part. So here we have the custom application built specifically to drive this system. So here on the right we have a 3D viewing window where we can see the gripper model as well as the 3D scan of the stock. To the left we have our jog controls. We have the speed control for the system and several other controls, as well as a readout of the robot's current status. In the 3D view control we can add in a grid. So this grid has line spacings of 10 millimeters. So from this grid we can measure roughly the size of the stock in all 3 coordinate planes. We can take out individual grids, put them back in. We can also remove the gripper, and if we had multiple 3D scans, we would see them displayed here in this list, and we would be able to select individual scans for viewing. We can also rotate the model, we can pan, and we can zoom in and out as you would expect. So here we can send the machine to the working position and get started. So now we're ready to start. The machine is going to first 3D scan the part, and then it will do the first forming operation, and it will continue to do this all fully autonomously. It has over 15,000 individual instructions that it will receive. One instruction might be to lower the arbor press, one instruction might be to raise the arbor press. So it's a lot of instructions. It'll take approximately 2 hours to complete this part. So let's get started. So there it is, that's our part. Why don't we take off this little extra bit here, and then why don't we give that one final scan. So, there it is. Let's have a look on the computer. So here we have the 3D model of what we started with, and we can look through the progression of the parts. So here's our final part. We can see we have a few cylindrical sections and a square cross section as well, and we were able to cut off the end. These tool paths were fairly simple. There was no real feedback from the scanner to the tool path itself. That part will come in the near future. But so far we've demonstrated reliability. The machine was running for over 2 hours unattended. The machine has been used to make this particular part 3 times now, with the result being nearly identical. The dimensions of the final part are not perfect. They're slightly oversized, between 1 millimeter and 1.5 millimeters. But the machine is coming along quite nicely. The next steps will be to take these intermediate scans and to formulate a new tool path based on the scan itself and the target geometry. So once we have that capability, we should be able to pull in a model from a CAD package like SolidWorks or Autodesk Inventor. And from the input model, we can create whatever part we want in the plasticine clay, and then eventually we will move on to making parts in steel by this methodology.